Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 1 for this week. And this is just sort of going to be a fun one, although admittedly I will insert a little bit of an opinion in here about something. But I'm not sure how many people have come out with their winter outlook yet. I don't think NOAA has, but I'm sure some other people have. And you may remember that last winter, there were a number of media outlets that shall remain nameless. And by the way, I'm in no position to criticize anybody in terms of them being right or wrong because I don't do this, okay? I've never issued a winter outlook. I don't because number one, I don't think that my skill level is all that terribly good on long range forecasting. And the other thing is, I think it's really easy for these outlooks to be misinterpreted, and I'll talk more about that in a little bit. So this is not me downing anybody that is right or wrong or whatever on this, but the bottom line is that a lot of people last fall said that, hey, we got an El Nino, above normal snowfall, we're going to break our snow drought. Guess how much we got at RDU? Zero, okay? Not even a trace, not even a flurry, not one single flake was observed, let alone measurable snow. And the one thing I will comment on is how many people that issued those forecasts came on radio, TV, or social media and said, I was wrong. Okay? Now, maybe somebody did. Okay, I don't know. I just know that I didn't see it because in the broadcast industry, it's a cardinal sin to admit that you're wrong about anything. You just can't do that. Okay, so I guess the point that I'm trying to make here is that supposing you hear a forecast for maybe below normal temperatures, or I'm sorry, let's do this. What if you hear a forecast for above normal temperatures and below normal snowfall? Okay, and you're sitting there thinking, oh, geez, I'm a snow lover, and this is going to be another useless winter. I can't believe this is going to happen again. That is an average over a, 90-day period, 91 if it's a leap year. It does not preclude the possibility of an anomalous event in the other direction, okay? The same way that if you hear a forecast for below normal temperatures and above normal precipitation, you think you're in like Flint and it's gonna be a snowy winter. And it turns out that all of the above normal precip occurs when it's mild, okay? And when it's below normal, it's dry, okay? So this is an average over a long period of time, and it doesn't tell you anything about the details, the specifics of day-to-day weather events, okay? So if it looks good, if you're a snow lover, it never is as good as it looks, and it's never as bad as it looks, okay? So what I want to do is go back through some historical data here, and hopefully this will make a little bit of sense. So this is historical snowfall data at RDU, and the way the snow season is defined is July 1st to June 30th. Now, it's not going to snow in July, August, September, and more than likely not in October or May or June. But that 12-month period encompasses the winter season, and they're sort of defined as like, 1954, 55, 55, 56, 56, 57, and so forth, okay? So I actually broke this down, and there's a site, it's called the Golden Gate. There's Golden Gate in the website, and it categorizes all the La Ninas and El Ninos since 1950, okay? And it takes a look at the whole 12-month period and categorizes each year as a moderate El Nino, a weak El Nino, a strong La Nina, whatever. So we didn't have any very strong La Ninas, but we had strong La Ninas, moderate, weak, neutral, weak El Ninos, moderate El Ninos, strong El Ninos, and a few very strong El Ninos, okay? So this was the probability of above normal snowfall and below normal snowfall for each one of those categories. And last year, we were in a strong El Nino. So you look at that and you say, okay, the probability of above normal snowfall is 10.5% in a strong El Nino and 5.6% for below. So it's not quite 2 to 1, but close. And the one thing that I pointed out last year when all these forecasts were coming out for above normal snowfall, and I'm going to talk about this now, is that if you combine all the La Ninas, if you don't worry about whether or not they're moderate, weak, strong, whatever, then the probability of above normal snowfall in a La Nina is 31.6%. For neutral conditions, it's 28.9%, and in an El Nino, it's 39.5%. This is only about 8% higher than this. And I'll try to find the video and provide a link so you can go back and look at it. But I think I did this late November of last year and said, don't hang your hat on this because the probability historically only goes up 8% over a La Nina year. In fact, the biggest snow we ever had at RDU in history in 2000 occurred in a La Nina year. Okay? So there's no easy correlation here whatsoever. Now you go down here and you see the probability of below normal snowfall is 36.1% in a La Nina and 33.3% in an El Nino. So a La Nina is not necessarily the kiss of death. It's only 3% or 2.8% more below normal than an El Nino, okay? Now, what I did then, instead of looking at the whole 12-month period, I just took a look at December, January, and February. And the way I evaluated that was that I said anything between minus 0.5 and plus 0.5 on this Oceanic Nino Index, I'm going to call neutral. 0.5 to 0.9, or minus 0.5 to minus 0.9, weak. 1 to 1.4, plus or minus, moderate. 1.5 to 1.9, strong. And 2 or above, very strong, okay? It doesn't change all that terribly much, but there were a few modifications. So we take a look at the strong El Nino, and when I did it that way, the probability of above normal snowfall actually went down 2.6%. Below normal didn't change. And if we take a look at a weak La Nina, this went up by 2.6%. And this one down here did not change. It was still 22.2, okay? If you lump them all together, again, you don't worry about whether or not it's weak, moderate, strong, or very strong, then it didn't change, I don't think at all, on the probability of above normal snowfall, but there were a couple of trade-offs in the below normal snowfall, okay? But the bottom line is you don't see any real glaring winners here, okay? That again, we've only got a less than an 8% difference between an El Nino and a La Nina, okay? Now, the last thing I did, and you know I'm a numbers freak, so I just had fun doing this, is that I took a look at the 4 combinations of temperatures and snowfall. Now, the one thing you do have to remember here, especially when it comes to temperature and also snowfall, is that the normals change every 10 years. And so the normal temperature has steadily gone up every time they revise the normals every 10 years. So out of the last 80, 50 years are below normal if you go by the current standards, and 30 years are above normal, okay? But if you actually went back, and I couldn't find this anywhere, if you actually went back and looked at the normals that existed at that time, then it would be about an even split. So the number of winters that ended up with below normal temperatures and below normal snowfall was 19. The number of winters with above normal temperatures and below normal snowfall was 27. As you might expect, the below above was the winner, although not by much, at 31. And then there were 3 winters, and this goes back to 1945, that had above normal temperatures and above normal snowfall. So if you heard a winter forecast for above normal temperatures and above normal precipitation, you might think to yourself, oh, it's going to be a rainy winter. But in those 3 cases, the snowfall was actually above normal. So I think these outlooks are probably very useful for energy companies and anybody that is worried about how much energy is going to be consumed over the entirety of a winter season. But I'm not sure that the general public really gets that much out of it, because I know, for me, being a snow lover, every time I hear below normal temps and above normal precip, my ears perk up and I say, this is going to be a neat season. And it doesn't always work out, okay? because, again, it might be cold and dry and warm and wet. And when you average it all out, it's below normal temperatures and above normal precip, but the two never get together and actually produce an above normal snowfall year, okay? So just a couple of notes here to finish up. In strong El Ninos, the probability of above normal snowfall is 10.5%, below normal is 5.6. In all El Ninos, it's 39.5 to 33.3. In weak La Ninas, which is what we're anticipating this winter, the probability of above normal snowfall is 15.8%, and below normal snowfall 16.7. So that's about a crapshoot there. But it is interesting to note that the 15.8% in I can't get my cursor to come up there. There it is. In a weak La Nina, it's 15.8%. And in a strong El Nino, which is what we had last year, it was only 10.5. Okay, so from a probabilistic standpoint, if we have a weak La Nina this year, actually about a 5% better chance of having above normal snowfall. And then in all La Ninas, the probability of above normal snowfall is 31.6% and below normal 36.1. So again, there is nothing to hang your hat on here at all. And anybody that tells you that there is a one-to-one correlation between El Ninos and La Ninas and snowfall in North Carolina, they're pulling your leg, because these numbers obviously tell a very, very different story. So I will try to find that video that I made last November, and if I find it, I'll put the link down there below the video itself. I may have to add it, later, because I want to get this out as soon as I can. But if I'm able to find that and put it up there, have a look, because I want you to know that I made that statement at that time that this is no guarantee, and as it turns out, it certainly was not. All right, folks, that's it for now. That's bonus weather video number 1 for this week. Hope you found that at least mildly interesting. Next one coming up on Wednesday, and the next daily weather update, of course, coming up tomorrow. So you all have a great what's left of your Monday evening. Let's go Mets, and we'll talk to you again tomorrow. Take care.